Okay, so back to page 58, the more complicated example here. So got figure 5 shows a model of a loaded section of a bridge made using a uniform wooden beam. So that's here. And if it's a uniform beam, then all the weight acts at the center of gravity. So wherever the center is, that's where the weight is going to be acting. So just there. The wooden beam measures 120 centimeters and has a weight of 15 newtons. So there's a 15 newtons there. One end rests on a support, so reaction force is there, and the other end is attached to a vertical string. So there's a tension here holding the uniform beam up on this side. And then we've got this extra weight here. So before we go further the question, I'm just going to discuss a few things. If I enlarge this picture, then the thing about trying to find unknowns. So say if you were trying to find the resultant force there, or the reaction force, then what you would do is you would take a pivot point at here at A. The reason you take the pivot at A is because you can ignore the tension, the unknown tension. If you take the pivot at A, then the moment about A due to this tension is 0, so you can ignore it. And then you can calculate the moment due to the 30 newtons, the moment due to the 15 newtons, and then that must equal the moment due to the reaction force there at that distance. So that's where you take that pivot. You can actually take pivots anywhere, but it's more useful to take a pivot where it'll cancel out an unknown, like the tension. If you took the pivot, let's say here at R, take the pivot there, then you could calculate the tension. So you could do the moment due to this 15 force at 60, or plus the moment due to this force at 30 newtons, must be equal to the moment of the tension. So you can make them equal and calculate the tension. So taking the moment about R at that point there, you can ignore the force here because it's the moment 0, so it cancels out. You could, if you wanted to, you could take a moment about the center of gravity, like that, and you could ignore this force, but then you'd have two unknowns. You'd have an unknown due to the tension on this side and an unknown due to the reaction at this side. So you'd have two unknowns, you wouldn't be able to solve it. So choose a pivot point where one of the forces will cancel. And well, the force you're not looking for is the one you want to cancel. So I'll work through this example on the next page.